In this video, we're going to take a look at graphing sine with transformations. Between sine and cosine, sine is the easier one to start with, although they're very similar because we are starting with the point 0, 0 and starting at the origin. We're going to look at graphing one cycle of the graph by going one rotation around the unit circle. So we're going to list out all of our quadrantal angles, pi over 2, pi, 3 pi over 2, and 2 pi. You could also use 90, 180, 270, and 360 in those spots. We're going to stick with radians because it's actually a little easier to make our scales when you're in radian measure. So sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. So let's label our scales. I'm going to graph the one cycle in red, although we'll continue the graph beyond that. So we'll plot those 5 points, 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi. And then sketch a nice curve in there. That's your one cycle. And that's the cycle that we're going to move around using the transformations that you're comfortable with from previous graphs that you've worked on in Algebra 2. I'm going to continue the graph because this is a graph that keeps on going forever to the left and right, and just use the same pattern that we graphed previously. So you get a few more waves on your graph. I'm just doing that in a different color so that it's still highlighting that one cycle that we're always going to start with. Now the transformations that we're looking at, we're skipping one of them for now. We're only doing 3 of the 4 possible transformations that we could be working with. We're focusing on A, which in front is going to give us the vertical stretch or shrink. And this vertical stretch also determines the amplitude, which is our distance from the midline. And then the negative in front of A is just going to be a reflect over the x-axis. Which means for our one cycle, instead of going up and then down, it's going to go down and then up. So just to give you a quick idea of what it will look like in the one cycle in red, it will go down and up again to get that S shape. The B value is your horizontal stretch or shrink. But more importantly, because this is a periodic function, it tells us the period of the graph. And the period is going to be the original full cycle, which in this case is 2 pi. That's how long it takes to go through one full cycle, divided by the B value. Or if you're looking at 360 or degree measures, it would be 360 divided by B. Again, we're focusing on the radian measures for this anyway. And then D is the vertical shift. We are skipping over C. C is our horizontal shift or translation, which you are definitely comfortable with from this year, but it adds an extra element of challenge to these graphs. So we're going to get the basics of the graph without adding that part in, and we will do this next year. All right, so we'll take a look at some examples. Our first example, we have an A value of 3. That tells us that our amplitude is 3. Amplitude itself will be positive. If it's negative, again, that will tell us if it's a reflection. Our B value is 2. So that tells us our period is going to be 2 pi over 2, or pi. And that will tell us how long it takes to go through one cycle. We want to squeeze the 5 points in there. So we're going to calculate something called the interval to set up our scale. And that interval is going to be the period divided by 4. We're focusing on the quadrantal angles, and the quadrantal angles split our axes up into 4 quadrants. Hence why we're dividing by 4. That's going to get us all the critical points. The 5th point is a repeat of the first point. So it's really 4 points that are different than each other, and then the 5th one is the repeat. So in this case, if we do the period divided by 4, we get pi over 4. And for now, we can use this as our x scale. If we add in the horizontal shift, you need a combination of that horizontal shift with the interval to determine your x scale. And again, that's something that you'll work on when we include that transformation. And then the last transformation is the -1. That's your vertical shift. You can either write that as -1 or down 1. All right, so before we do graph this, for now, just to get the hang of this, we're going to graph the vertical and horizontal stretch first, and then we'll do the translation. And there are many different ways that you can start the setup of this. So we are going to start on 0, 0, even though that point's going to move down 1. Do this lightly in pencil. On our y scale, we want to go up to 3 and down to -3 for now. We might need to move more than that, so I'll label more because we are shifting it. And then for our x scale, we want to make our x scale go by pi over 4. 2 pi over 4 would be pi over 2. 3 pi over 4, and then 4 pi over 4 would be pi. So when we go over to our next point, we want to go over to pi over 4 and up 3, because that's our a value or amplitude. We'll go over one more of our intervals and back down to the axis. Go over another one of your intervals on the x scale and go down the amplitude or down 3, and then go back over one more and up to the axis. So this is the graph. Again, lightly sketch that in before the vertical shift. And then we just can take all of those points and move them down 1 to get our graph after the vertical shift. The horizontal is not as easy, again, because you have to match up the x scale. So what I have in red is my 1 cycle. And then I'm going to switch over to purple to graph the rest of it. And you want to graph, again, like we did before, the same pattern. Just make sure you line up your points to graph more cycles. And then same thing here, goes a little further out. And just fill up your graph with as many points as you can. So we can get like 2 and a little bit cycles on here. The other thing you can do to help you see the midline is to just sketch a dotted line going across at -1. That's another way you can start the graph right on there. But for now, drawing the original graph and then moving it is a good way to see what's happening. Our range of this graph is going from -4 to 2. And then the critical points are just going to be the points from the red graph. So we have 0, -1, pi over 4, 2, pi over 2, negative 1, 3 pi over 4, negative 4, and then pi, negative 1. So you can also see the range within those points, the lowest and the highest of the y values. We're going to end this first video here and do a short video for the second graph example.